This is one of the most easiest chapter, work, energy and power. Okay, so first let's understand what is work. Correct. Work is nothing but what generally force into displacement. Okay. So work is a scalar quantity. Is it a scalar quantity or vector quantity work? What do you think? Is it a scalar or vector work? What quantity is it? Is it scalar or vector? It's a scalar quantity. How can we say is nothing but once you go to higher classes, FD cos theta will come. Okay. For all the scalar products, we'll use what? Cos theta. Whereas if I take torque, torque is nothing but force into perpendicular distance. Okay, it is called cross product here. So this is again in your higher classes, not now. This is dot product and cross product. With dot product, we'll have cos theta. With cross product, we'll have what? Sin theta. We'll have what theta? Sin theta you will have into sin theta. So torque is a vector. If sin theta is coming, it is a vector. If cos theta is coming, it's a scalar. Once you go to your higher classes in the next year, you will get to know. But generally, what is work force into? See, suppose we are doing some work, which means I am pushing one table from that point to this point. So I am applying a force, and that table or chair is moving that particular thing. That's nothing but our force into displacement. Correct? So that is the actual meaning of what the work. But I can see in the textbook, work is given as Fs cos theta. W is equal to Fs cos theta. S is nothing but displacement, cos theta is there. But I told you what is the reason cos theta is coming. Cos theta is coming because first thing, it is a dot product thing. Second, it can be represented in one-dimensional form. So if it is 2D or 3D, we use cross product. If it is one-dimensional, we use dot product. 1D, we use dot product. This is out of textbook which I am just teaching. Fine. And when will be this force work done maximum? When theta is equal to 0, cos 0 is what? 1. So which means you have to be good in trigonometry also. So W is equal to what? Fs. I'll get. So this I can just put it in what? This kind of boxes. When this particular, this whole thing. Correct? W is equal to Fs. When it will be minimum? When this will be minimum? When theta is equal to 90, if I am putting what is cos 90 value? 0. So W is equal to 0. Clear? So these are the important cases which they can ask in the examination. But normally W is equal to what? Fs. Fs cos theta or what? F into S respectively. Correct? Suppose if the work done is by gravity. Okay. Let's see if the work done is by gravity. So there are two work done. Okay. One is the positive work done and other is the negative work. If we want to know what is the negative work done, just imagine the lift. Correct? Lift going upwards. It is against the gravity. So in order for the lift to take us upwards, correct, the work has to be done. So those kind of work done is called what? Negative work done. So negative work done is nothing but to move, work done to move against the, or work done against the, work done, I'll write down here, work done against the force of gravity. That is nothing but our negative work done. If you're able to understand the meaning of each and everything like this in a very simple fashion, very easy for us. Okay, for me, teaching you this is very easy, no preparation. Okay, absolutely no preparation for teaching you any of the topics. Because how did I learn? I learned it by the meaning. Okay, your work done is against the gravity, negative work done. Correct? If work done is on the same phase of the gravity, it is positive work done. Correct? So what will be the work done formula here? Write a new page. Gravity, force is there, displacement is there. Force is equal to mass into acceleration due to gravity, mg. So when substituting this, you'll get mass, mass. Not a double s is not there, mass. Okay, or I'll get mgh, whatever you can do. S is displacement, or you can get mgh also. Nothing wrong in this. So different text to different things. Okay, but end of the day, we have to know the concept. That's all. Correct. Now next topic is power force. How to remember this power? Okay, I'll tell you the simple shortcut formula for this. Draw a triangle. Fine. Put work. What? Work here. P and T. So this meaning W is equal to P into T. This is not the cross product and dot product. Okay. W is equal to what? P into T. This into this. But what is P is equal to? Work done to time. W by T. So if you can able to memorize this triangle, it will help you out in the long run. You can use it for anything, literally for anything. So P is equal to what? W by T. So this is nothing but work done per time taken. Correct? Work done per time taken. So the unit of work done, they may ask you that I didn't explain. Unit of this is in joules or joules, whatever you feel like. The power, watts. Bulb is there, right, at home. For example, let's say take for an easy thing where we need not need much power. We use what? 0 watt bulb. 0 watt bulb. Correct. For example, if I need, for example, let's go to the jewelry shop or textile shop where there is high brightness. They may use what? 20 watt bulb. Clear. So what is the unit of power? If someone asks you what is the unit of power, then you should answer them watt itself. Watt. But not WHAT, it is WATT. Watt. Watt is the unit of power. So instead of this, you can just replace and write what? What is the unit of power? So if you are able to learn like this, things will be very easy for us. Correct? Yeah. Any doubt up to this? Let me know. Whatever I taught, okay. Whatever I taught, that's it. 3 doubts are there. Check. Yeah. End of session, you can ask me the doubt. Fine. End of the thing, you can ask me the doubts. Let me just complete this thing. Hardly 2 more minutes. End of session, you can ask. Keep whatever doubts are there with you. Last topic, energy. So first thing is draw the triangle. Correct? Draw the triangle. EPT. Same thing here. Instead of work, I'm just substituting what? Energy E. So energy is equal to what? What is energy? Power into time. Power into time. That's all. Correct? What is power? Power is nothing but, if you ask me what is power from this definition, rate of, correct? It is the rate at which the energy is transferred. The rate in the sense the rate of time. Correct? The power is nothing but rate at which the energy is transferred. Rate meaning what? Time itself. Fine. This is our energy thing. Example number 3. Right? Correct? So first thing, mass of the boy. Mass of the boy, MB, 40 kg. Correct? And then what is it? Mass of the girl, mg, 30 kg. So even if I don't put these things, you should be able to put it up. Okay, mb and mg. Next, in the question they're telling the compare the work done. Second thing is compare the work done. Second thing is power divided by them, and they given g is equal to 10. Okay, g is equal to 10 they have given. So first thing, even if you don't know anything, you should start with what? Force formula. Formula used for force. F is equal to what? Mg. So here in the first one, force by the boy. F1 is equal to what? Mass of the boy into gravity. Gravity is given 10 in the question. So 400. 400 Newton. F2. F2 is equal to mg into 10. So 300 Newton. So first, we, after finding the force, then total height climbed. They given that a boy of mass 40 kg climbs up a flight of 30 steps, each 20 centimeter high. Correct? Each 20 centimeter high. So suppose if he's climbing one step, this is the steps actually. Each step is how much? 20 centimeter. 20 centimeter. This is also 20 centimeter. Correct? So we have to calculate the total height of this. Total height. So that is nothing but number of steps into height of the steps. So if you can visualize this thing, it will be very wonderful. Number of steps into height of each step. So number of steps he takes is how much? 30 steps he takes. Use another color. 30 steps he'll take. So 30 into height of each step is 20 centimeter. So totally the height is how much? 600 centimeter. If I want to convert to meter, divide by 100. If I want to convert to meter, so I can write here meter. So it is nothing but 6 meter. Correct? Now we have to calculate the work done by the boy, because the first question is compare the work done. Work done by the boy, WB. Force into displacement. What is force? 400 Newton. Number of steps is 6 meter. So 6 force is 24, 22,400 joules. Unit of work done is joules. Similarly for girl also. Girl is 300 Newton. Into same thing. Steps is same. 3 6 are 18. 1800 joules. Fine. They're telling to compare this. Then what do you do? Just we do W1 is to W2. W1 is to W2. So just 2400 by 1800. Cut these two things. Which one? Zeros and all you cut off. 6 4s are 24. 6 3s are 18. 4 is to 3. 4 by 3 or 4 is to 3. Second thing is power developed. Power. Draw the triangle. For power thing, draw the triangle. Always don't forget to draw the triangle. Correct. Now write down work done, power into time. Correct. So P is equal to what? W by T. Correct. So power of the boy, PB, is equal to work done. Work done is coming as what? 2400 by time. Time 1 is given as what? 2 minutes. 2 minutes in the sense 120 seconds. 120 seconds. So 12 to the 24, we get 20 watts. Similarly, we will do it for the girl also. Work done is 1800. But for the girl, 1.5 minutes. So 1 minute is 60 seconds. 1.5 is 90 seconds. So 9 to the 18. Correct? So this is also 20 watt. So the power developed is same. The power developed by the boy and the girl is same. Because P1 is to P2 is 20 by 20. 20 is to 20 or 1 is to 1. So let me record this thing. So numerical pump problem. 8 to 1. Right? This particular question. 8 to 1. A pump is usually 500 kg. Okay, fine. Mass is given. Depth of 80 meter. Perfect. Height is also given. 10 seconds time is given. Work done by the pump. Power at which pump works. Efficiency. So this may be something which is new to you. First thing we have to understand in this kind of question is what is meant by efficiency. Efficiency is nothing but output by input. For example, if the teacher is teaching 100, for 100 marks she is teaching, the student is getting 90 marks, then the efficiency of the student is what? 90%. So that's how it is actually. Fine. So efficiency is nothing but output to input. The ratio of output to input is called what? Efficiency. Whereas in this question, we can clearly see 500 kg mass is given. Mass is 500 kg. Height is given, that is depth 80 meter. Gravitational find 10 meter per second square, whatever. Acceleration or whatever it is. Time is also given, t is equal to 10 seconds. What is the work done formula? W is equal to mgh. This is the formula we have to use first. Okay, once we are done with this formula, what is work done is equal to mass 500 into g is 10, correct? H is 80. So I'll get what? 8 5s are 40. Correct? Then add these zeros and this one. 4 zeros into 10 power 4. Or else I can write 4 into 10 power 5 joules. That's it. 4 into 10 power 5. This is the first thing. Second thing is power. So I told you for power, we have to do what? Power write down here, time here, work here. Power is equal to W by T. W just now I found out what? 4 into 10 power 5. Correct? I hope it is 10 power 5. Yeah, it is 4 into 10 power 5. By time is 10 seconds. Cancel this 10 power 4. So I'm getting 4 into 10 power 4. So power P is equal to 4 into 10 power 4. Or else I can write 40 into 10 cube. These are all watts. 10 cube is nothing but kilowatt. 40 kilowatts I can get power. The next thing is efficiency. Efficiency is nothing but what? This is efficiency symbol eta. Efficiency is equal to output power by input power. Output by input. So in the question they are given, the efficiency is 40%. Correct? 40% is the efficiency. Output power by input. Output we don't know what it is. Sorry. Output just now we found out what is output power. Input we don't know what it is. Input power we have to find out. This particular thing. What is my output power in this? 40 kilowatt. Correct. So 40 by input power. So 40% is nothing but what? 0.4. 0.4. 40 by 100. That I'm just writing it as 0.4. Okay. Is equal to 40 by input power. This implies 0.4 is equal to 40 by input power. So we'll get the answer as this will go 100 times. So input power is equal to 100 watts. 100 kilowatt because I'm measuring everything in kilowatt. Now let us check our answers in the back, whether it is coming correctly or not. So 40 kilowatt, 100. I think all the answers are correct.